This is a continuation of the previous video, probability distributions 1. And in this video, we will discuss Poisson distribution introduced by Simon D. Poisson. If the variable by which the data is generated can be considered as number of occurrence of an event in a specified interval, the data can be modeled using Poisson distribution. For Poisson distribution, there is only one parameter, the average number of occurrence, denoted by Greek alphabet lambda. Hence, the distribution is usually denoted by P lambda. We can take a number of examples for Poisson distribution. Number of cancellation of orders by customers at an e-commerce portal, number of customer complaints per day, number of typographical errors in a book. All these situations represent number of occurrence of an event in an interval, hence can be modeled using Poisson distribution. Next, let us come to the properties of the distribution. The first property is mean of the distribution is given by the parameter lambda. Second one, variance of the distribution is also given by parameter itself. That means mean equal to variance. This is a characteristic property of Poisson distribution. Third one, the distribution is positively skewed and leptokurtic in general. But as the value of lambda becomes larger and larger, it approaches to symmetry. Finally, the probabilities associated with Poisson distribution can be obtained using the probability function given by P of x is equal to e raised to minus lambda, lambda raised to x by x factorial, x is equal to 0, 1, 2, 3, etc. Where this e represents exponent. The following Excel functions can be used for the calculation of Poisson probabilities. Probability mass function, that is probability x is equal to small x, can be calculated using the function Poisson.dist x comma lambda comma 0. Cumulative probability, probability x less than or equal to x, can be calculated using Poisson.dist x comma lambda comma 1. That means there are three arguments for the function. The first one is value of x. Second one is value of the parameter. Third one is a logical value, 0 for mass function and 1 for cumulative probability. Next, as in the case of binomial distribution, we have the following remarks. Probability of x greater than x can be calculated as 1 minus probability x less than or equal to x. Probability a less than or equal to x less than or equal to b can be calculated as probability x less than or equal to b minus probability x less than or equal to a minus 1. This means probability from a to b will be equal to probability up to b minus probability up to a minus 1. We will conclude this discussion after describing two examples. The first example is given as follows. Average number of traffic accidents on a certain section of highway is 2 per week. We have to find out. Question number 1, probability of no accidents on this section of highway during 1 week period. Second one, probability of at most 3 accidents on this highway on a 1 week period. So both these questions are on the number of accidents per week. Number of accidents per week can be considered as number of occurrence of an event, hence can be modeled using Poisson distribution. It is given that average number is 2 per week, hence we can use Poisson distribution. Now let us come to the first question, probability of no accidents. Probability of no accidents means probability x is equal to 0. This can be calculated using the Excel function and you will get the value as equal to 0.1353. The next question is probability of at most 3 accidents on this highway on a 1 week period. At most 3 accidents means probability x less than or equal to 3. This can be calculated using the Excel function, and you will get the value as equal to 0.8571. Next, I will show how these probabilities are calculated using Excel. I will open an Excel file and illustrate how these probabilities can be calculated. The first one is a probability mass function. Hence, I can use Poisson.dist function equal to Poisson.dist. Our arguments are: first one is a variable x, that is 0. Second one is a parameter lambda, that is 2. And third one is the logical value. Here, since it is mass function, it should be equal to 0. I can enter, I will get the value. Similarly, the second probability is a cumulative probability. That also can be calculated using Poisson.dist function, taking the logical value as 1. So here it will be Poisson.dist. X value is here 3, lambda value 2, logical value 1. Finally, we will discuss one more example. The average number of calls arriving at a call center is 10 per hour. You are asked to find out probability that no calls received in a 3-hour window. The probability that number of calls over a 3-hour period will exceed 30. So we are discussing number of calls arriving. Number of calls arriving. This can be considered as number of occurrence of an event. So you can use Poisson distribution. You are given average number of calls is 10 per hour. 10 per hour. But in our problem, we are considering 3-hour window. So our average is not 10, the average is 30. Since we are considering 3-hour window, average in a 3-hour window will be 30 calls per hour. Therefore, we can use Poisson distribution with the parameter 30. First probability that no calls are received. You can use probability x is equal to 0. Now you can use the Excel function for the computation of that probability. I am not showing that one. You know how to do that. Next one is probability that the number of calls over a 3-hour period will exceed 30. Will exceed 30 means will be greater than 30. Greater than 30 can be calculated as 1 minus probability x less than or equal to 30. Why? I cannot calculate x greater than 30 directly. But I have the Excel function for calculation of cumulative probability. So I can calculate a probability x less than or equal to 30, and I will subtract this probability from 1 to get the final answer. In the next video, we will discuss normal distribution. Thank you.